Right, find a polynomial function of least degree. Well, it looks like a negative. This looks like a negative x to the fourth graph to me. Okay, right, let's take a look at the x-intercepts. We have negative 2, so it's come from x plus 2. We have positive 3, so it's come from x minus 3. Now we also have positive 1, so it's come from x minus 1. But can you see it touches and turns? So there'll be 2 of them there. And there you go. That will give me an x to the fourth graph. 1, 2, 3, 4. Okay? Right, so that's basically what I have right now. But if I set x equal to 0, what's my y-intercept? Right, x equal to 0, that'll leave me with 2. This will leave me with negative 3. This will leave me with negative 1 squared, okay, which is positive 1, okay? Negative 1 squared, okay? Right, this equals negative 6. That should be my y-intercept, but you can see it's not. It's 3. So again, this is 1. Now you might be able to just figure that out for yourself, that you need to halve it, but if you need to put an a in front, okay? So what we're saying here is that what's in front when x is 0, right, again, remember, that's 2. This is negative 3. This is negative 1. And that should equal 3. Okay, it should equal 3 because that's what this is showing right here. Okay, the y-intercept should equal 3. But I'm getting negative 6 because that is that there. That's that negative 6. Okay? So if I divide both sides by negative 6, which is the number next to the letter, a equals negative 3/6 or 1/2. So this up here should be negative 1/2. And that is the answer right there. Okay? And again, there's the negative. Right, let's keep on going. Solving a polynomial inequality. All you need to do is factor this and put it on a number line. The zeros are positive 4 and positive 1, okay, the zeros. Right, let's test an area. I'm going to test a number from here. I'm going to test 0, okay. Now again, if I put 0 into here, if these are 0, can you see this is saying, is 4 greater than 0? Yes, it is, okay. So, negative infinity to this 1 works, parenthesis, because there's no equal sign. Sorry about that. Dogs are going crazy. Now, if you test over here, this area also works. Okay? So this is also going to work. 4 to infinity, that also works. Okay, but again, test all the areas. Okay, so let's look at anything else on here. The factor theorem. This is the factor theorem. Now, if it works, 3 will be a 0, can you see? So I'm going to do 3 in my synthetic division. So 1, 3, negative 10, and negative 24. Bring down the first number, that doesn't change. Here's how it works. 3 times 1 is 3. Add those two together, you get 6. 3 times 6 is 18. Add those two together, you get 8. 3 times 8 is 24. And can you see, yes. So what's left is 1, 6, and 8, which is 1x squared plus 6x plus 8, okay? Now, if I factor that, that will give me the other two solutions, okay? So can you see 3 works? What does it want? All the zeros. So negative 4 also will work, and negative 2, because those will be the zeros, okay? Now, we're not doing any of these here, but just a quick reminder that this would be done by synthetic division because you can't factor it. But remember, the numbers to use will be a 1, a 2, a 13, or a 26 if you're going to do synthetic division, because of course you need to make 26 at the end. I think this is one that gives you maybe some i's, but we don't have to do this one. It's still just more of the same thing, synthetic division. You could do this synthetic division as long as you need to use a 1, a 3, a 9, or a 27, because those are the numbers that make the 27. But this can actually be done by factor by grouping. But anyway. Okay, now then, these are definitely the test. Okay, so want to write an equation based on the information here, or if it's graphical, all right? So if we have vertical asymptotes of negative 2 and positive 6, these are the denominators, x plus 2 and x minus 6. If we have an x-intercept of 2, it's come from that. So that is me building everything up from the asymptotes on the denominator and the x-intercepts on the numerator. The problem is that this will not give me a horizontal asymptote of y equals 2, because this is x minus 2, over x squared. What's that? Negative 4x minus 12. This should have a y equals 0 horizontal asymptote because the degree is bigger on the bottom, and it doesn't. So this is going to have to be x squared. It's also going to have to be 2x squared because that will give me the 2 over 1 to give me the horizontal asymptote. But now this is not going to give me the correct x-intercept, okay, if I set that equal to 0. What I need to do is this has to be 8. Now you have to kind of figure this out yourself, all right? The reason why is here we go, 2x squared minus 8 equals 0. This has to be my numerator. Again, the x squared minus 4x minus 12 is definitely on the bottom. And the reason is if I solve this, okay, we're going to have this. Well, I can do it factoring. I can also do it by adding an 8 to both sides, dividing by 2. And that's why if I square root that, I'll get plus and minus 2 as an x-intercept. Well, there it is. So this must be the correct answer, okay? That right there. Okay, so let's take a look at some of the graphical ones. These are a little bit easier, some of these. I'll do both of these. Right, this has asymptotes of negative 2 and positive 2. So here we go. That must be my denominator. I'll write it as x squared minus 4. Okay, x minus 2, x plus 2. Right, I also have an x-intercept of negative 1, so x plus 1, or x plus 1 over here, doesn't matter where I write it. Okay. Now, actually, that's the answer right there. Either one of these is the answer because, look, if I look at, if x equals 0, okay, for the y-intercept, that's 1 on top, negative 4 on bottom, then that's what I have right there, okay? And that's it. Well, let's try this next one. One more time. Okay, this has a vertical asymptote. This is actually x equals 0, so all I've got is that on the denominator. It's got an x-intercept of 1, so x minus 1. Okay, so that's all I can see so far. Again, numerator, denominator. But look, it's got a horizontal asymptote of 3. If I leave this like it is, that gives me a horizontal asymptote of 1, okay, because the order is the same. So I need to make this 3. If that needs to be 3, then that needs to be 3, all right? And that, I believe, should be the answer. Let's take a look at some more stuff. Okay, oh, now this is missing the actual question here. I think this is saying is this, as x goes to 2 on the positive side, okay, so this is the x equals 2 line, and this side over here is the positive side. So as it heads towards 2 on the positive side, can you see that y, f of x, is going up to positive infinity, okay? As x goes to 2 on the negative side, so this is the negative side of this line, okay? Can you see the graph is going down to negative infinity, and that's what that means. One more. Same here, as x, I think this is again, it's gone a little bit weird as this. Right, as x goes to infinity, so as x goes to infinity, can you see that f of x is heading towards this y equals 2 line, f of x equals 2. So that's just that, okay?